Hello juniors, today we're going to see electronic assignment number 11 corresponding to functions. We're going to see the different forms for the equation of a straight line. So the objective for this class is only one. It says identify and apply different forms of the equation of a straight line. Okay, so there are three different forms of expressing the equation of a line, which are the three you have over here, right? The first one is called the gradient intercept form, which is the most common form that you always remember, y equals mx plus c. We're going to see what each of the letters mean later on. Second form, it's called the point gradient form, which is how you see here, y minus y1 equals m times x minus x1. And finally, the general form, which is ax plus by plus d equals 0, where a, b, and d are all integer numbers. Remember, integer numbers are numbers that can be positive or negative, but must always be integers. They cannot be decimals. Okay? So, for the first form, we have the following. It says the equation of a straight line written in the form y equals mx plus c is said to be written in the gradient intercept form. So, a question for you to reflect. Try to think about this. Why is it called the gradient intercept form? If you remember, and try to understand what each of the letters represent, you'll remember that m, I'm going to do it with a different color, m represents the gradient of the function, gradient, and c represents the y-intercept, right? So that's why the name is gradient intercept form, because in this form we're given the gradient and we're given the intercept. So gradient intercept form. That's why the name is gradient intercept form. Then for the second case, it says the point gradient form of the equation is what we've seen up there, y minus y1 equals m times x minus x1. In this equation, the parameters tell you the gradient m and a given point, which is x1, y1, that lies on the line. So once again, why is it called the point gradient form? If we analyze the equation, it says y minus y1 equals m times x minus x1. For this particular equation, we're given a known point which has coordinates x1, y1, and we have the gradient, right? Which, as the previous equation, is m. Okay, so we're given m and a known point which has coordinates x1, y1. That's why it's called point gradient form. Okay. Last but not least, we have the third form. It says a third form of the equation of a line is a general form, ax plus by plus d equals 0. In this form, you may be told to use integers for a, b, and d. Okay. So let's see an example, and we're going to try to determine in both examples, a and b, we're going to write the three forms of the equation. The gradient intercept form, the point gradient form, and the general form. So it says, find the equation in all three forms of the following lines. So we're going to start with part A. It says the line that passes through point -4 and 5 and is parallel to the line with equation y equals -1/2 x minus 3. So we're going to start by doing the first one, which is the gradient intercept form. Gradient intercept form. If you remember, this is y equals mx plus c. So in order to write the equation in this form, we need the slope or the gradient of the line, and we need the y-intercept, right? So how can we get these two pieces of information from this exercise part A? we're given the information that the line is parallel to this line over here. So if you remember from last class, the condition of two parallel lines is that the slope of the first line equals the slope of the second line. So by looking at this equation, you should already identify that this is the slope of the equation and this is its y-intercept, right? So this would be the value of m, right? Because we're talking about parallel lines. So here I'm gonna write that m equals -1/2. Okay, then we need to calculate the intercept. We're given a point of the line, right? So if we're given a point, we could use that data as y and x, right? And plug in those values in order to find the value of c. So if we plug in this point, we will get 5 equals m, which is -1/2, x, which is -4, plus c. And if we solve this, this is a +2 plus c. So the value of c is 3. So finally, the equation of the line in gradient intercept form would be -1/2 x plus 3. And that's it. Okay, then we have the second form. The second form of the equation of a line, which is point gradient form. Point gradient form. If you remember, this is y minus y1 equals m times x minus x1. This is the second form of writing an equation of a line. Okay, so for this case, we need a known point and the slope. We already have those two pieces of information. We have the known point, -4, 5, and we have the slope, right? So the given point is -4, 5. That means that x1 would be -4 and that y1 would be 5. And the slope is the same, -1/2, the same as in the previous case. So the equation would be y minus 5 equals -1/2 of x minus -4, which would end up being +4. So you see that in this particular exercise, this type of writing the equation is easier than a gradient intercept form because of the pieces of information we're given. We're already given a known point and the slope, so we can use those two pieces of information to write the equation directly without having to do any extra calculations. And finally, to find the general form of the equation, this would be, to find the general form, we could start by writing in any of the two equations we already calculated, and what we need to do is take all the terms to the other side. Remember, I'm going to write the equation first. The general form of the equation, is ax plus by plus d equals 0. So we have the equation written this way already. What we will do is take these two terms to the other side. So we will get +1/2 x plus y minus 3 equals 0. So you see that we already have kind of what we're asked here, but generally we're asked to have these coefficients a, b, and c, and d, as integers, right? But 1/2 is not an integer, that's a decimal, 0.5. So in order to have all these coefficients as an integer, what we do is we multiply the whole expression by 2, which is the denominator over here, in order to eliminate the fraction. So we'll have x, 1 half times 2 is 1, so this is x, plus 2y minus 6 equals 0. And this is the general form of the line in this case. General form of the equation of this line. Okay. So that's it for exercise part A. And we have part B, which I'm going to do some space here. For part B. Part B. Okay, you see that there's an observation here, which we're gonna discuss only. It says, how can you verify that the answers obtained are equations of the same line? How do you know if this equation is the same as this or the same as this? How can we be sure about this? One way to be sure about this is, for example, in this case, you can do the distributive here and then take this to the other side, and you should get the same equation we have written here. Or from the general form, we could try to reorganize this and leave y alone. We can take this to the other side, take this to the other side, take the 2 dividing, and once again we should get the same equation as we have here. If we can verify that, then we can be sure that the answers obtained are equations of the same line. Or another alternative would be to graph using your calculators. You can go to menu graph, insert this equation, this equation, this equation, and then put draw, and you should get one same draw, only one drawing for the 3 equations. If you get only one drawing, then that means that all of these equations correspond to the same line, and that means you did the exercise correct. Okay, so let's go to part B. It says the line, so find the equation for the line that passes through these 2 points. So in this case, we're given 2 known points. We're not given the slope like we had in part A. So for this case, if we have 2 known points, we can calculate, remember from last class, we can calculate the slope first by applying the formula that you have in the formula booklet, y2 minus y1 over x2 minus x1. And once we have the slope, you can do the same thing we did in the previous exercises to find the 3 equations. So the slope would be, the points are, this would be -4 minus 2 divided by 3 minus 1. So this is -6 divided by 3 plus 1, which is 3 plus 1, which is 4. So we get that the slope is -3 halves if you simplify this. Okay, so once we have the slope, we can find the 3 equations. The first one is the gradient intercept form. We could say that this is y equals mx plus c. We have a given, we can pick either of the 2 points. I'm gonna pick this one and replace it into the equation. So this would be 2 equals, you can try this by your own if you want, people. You can pause the video and try it on your own. -3 halves times -1 plus c. So then we calculate the value of c. This is 2 equals positive 3 halves plus c. So the value of c would be 1/2. 2 minus 3 halves, that's 1/2. So finally the equation would be y equals -3 halves x plus 1/2. That's it. For the second equation, which is the point gradient form, we just need a given point and the slope. We already have that, so this would be 1 minus, I'm going to use the same point, this one, 1 minus 2 equals the slope, which is negative 3/2 times x minus the given x point, which is negative 1, so this becomes positive 1 here. So, and that's it. This is the equation in the second form. And in the third form, the general form, remember, we have this negative 3/2 x plus 1/2. The first thing is to take all of the terms to the other side. So this would be 3/2 x plus y minus 1/2 equals 0. And then since we need all coefficients being integer numbers, we multiply all of this by 2, which is the common denominator in this case. So we'll have 3x plus 2y minus 1 equals 0. And this is a general form of the line. So there you have the three different types of equations. Then it says reflect. What are the key features of the graph of a line? By observing of the equations, what are the key features that we always need in order to calculate the equation of a line? There are two things, or three things mainly: the slope, the intercept, or a given point. With those pieces of information, we can always calculate the equation of a line. Then, what are the three different forms of the equation of a line? That's what we've seen already. What is the relationship between the parameters in each of the forms of the equation of a line, and key features of the graph of the line? Okay, those are things that we already discussed. Then, second reflection. Which form or forms of the equation of a line have parameters giving a point on the line and the gradient? Well, in this case, it's the first and second form, right? The gradient intercept form, and the second case, which is the point gradient form. Yes, point gradient form. If you see the general form of the equation, the general form, which is this one, this doesn't give us any piece of information of the line. That's why it's not commonly used to express the equation of a line. Okay, finally, finding the intersection of two lines using your graphic display calculators. In this example, I'm going to show you how to use your calculator in order to find the intersection between two lines or between two curves in general. Okay, and I'm also going to refresh you how to find the intersection by hand. So it says if two lines intersect, you can use your GDC to find the point of intersection. I'm going to show you how to do it by hand first, and then I'm going to show you how to use the GDC. So it says for part A, find the intersection between this line and this line. So the first equation is negative 3x plus 1 and negative 5x plus 3. When we're asked to find the intersection point, we're asked to find the common point that the two lines have, right? Let's say that the graph of the first line is something like this, and the graph of the second line is something like this. The intersection point would be this point over here. And how do we calculate this point? You know that at this point, both equations are the same, right? That means that we can equalize both equations. So if you understood that, you know that what we need to do here is basically set this equal to this. So the equation would be negative 3x plus 1 equals negative 5x plus 3. So if we solve for x, this would be 2x equals 3 minus 1, 2, and we get x equals 1. So the x coordinate of the point of intersection is 1. And to calculate the y coordinate, we just plug in this number into any of the two equations, the first one or the second one. The result would be the same. So if we plug in into the first equation, we would get that y is negative 3 times 1 plus 1, and this gives us negative 3 plus 1, negative 2. So the point of intersection in the first case, intersection, has coordinates 1, comma, negative 2. That's the point of intersection. Okay, how do you perform this using the calculator? If you follow these steps here, there's a summary of the steps you need to follow. You can try this with your own calculators. We have the same example. It says use your GDC to find the point of intersection for each pair of lines. The instructions are the same for the calculator with color and the ones you have. So try doing this on your own. You go to menu 5, which is menu graph. To display the equation entry, you should get this. So then type the first equation, which is this one over here, and this as y1. And then the second equation you plug in as y2. Okay, so you should get something like this. After you plug in both equations, you go to draw. Press draw to display the graph screen, and you get the equation of the two lines. The GDC now displays both straight lines, y1 and y2, as seen over here. Maybe you need to set up your axis if you don't see the lines properly. Remember, in order to do that, you can do Shift Zoom Auto or Shift VWin. So Zoom Auto, or you can go to Shift VWin and change the X and Y scales. Then for step number 3, it says to find the intersection, press F5, which is Gsolve, and F5 again to intersect. And then press execute, and the calculator will give you these values over here, which represent the intersection point. Okay, here it says that GDC displays the intersection of the two straight lines at point 1 and negative 2. So the solution is 1 and negative 2. And in the exercise which we solved manually, we got 1 and negative 2. So this is a way to perform the exercise manually, and this is the way to perform the exercise using GDC. You should know both, as in paper 1 exercises, you are not allowed to use calculator. Okay, so we're gonna quickly do part B in order to finish this assignment. For part B, you could try this using your calculator. I'm gonna do this manually. If we have the equation of the first line, which is 2x plus 5, and the second equation is written in general form, 3x plus 2y minus 12 equals 0. In this case, what we could do is we could plug in this y into this equation. Instead of writing y, we're going to write 2x plus 5. So by doing that, we're going to get 3x plus 2 times 2x plus 5 minus 12 equals 0. And then we solve for x. This is 3x plus 4x plus 10 minus 12 equals 0. This is 7x equals 2. So x equals 2 over 7. So if we plug in this value into the first equation, for example, we would get, I'm going to do it here, y equals 2 times 2 sevenths plus 5. So y equals, this is 4 sevenths plus 5. 5 is the same as saying 35 over 7. So the answer should be 39 over 7. So the intersection point in this case would be, I'm going to write it up here. Intersection point has coordinates 2/7, comma 39 over 7. You can try doing this with your calculator and you should get the same answer. Okay, so that's it for this assignment, people. If you have any questions, you can always ask in the Google Classroom.